All righty. Hey guys, how we all doing today? So we are going to continue going through this final hodgepodge chapter here with complex with oh, trigonometry here. Um, so we talked about complex numbers back at the beginning of the year and about how everything is based on a real number system or a complex number system. I'm sorry, were able to graph them where we had our imaginary axis. So we call that the B axis. And we had our real number axis, which we called it the A. And then we were able to go through and graph a whole bunch of points. And we called those points some Z value. And we said Z is A plus BI. And so we were able to get our A coordinate, which is really the X, and the B coordinate, which was really essentially a Y. We were able to graph it on an XY axis. And so we dealt with that earlier in the year. And then from there, we were able to actually figure out what the absolute value is, or the distance it was from 0, 0. We call that, well, we're going to call that R. Originally, we called that the absolute value of Z. So R is equal to the absolute value of Z, which is right here. And so we dealt with the absolute value back in the first semester. So we basically said, well, it's just going to be some Pythagorean theorem, which is what we see right here. But what we're going to do today is we're going to take this and go from writing this as a from complex form, and we're going to go and write it in what we call its trig form. So instead of A plus BI, we're going to write it in its trig form, R cosine plus R sine theta I. And now if we factor out the R, we end up with this cosine theta I sine theta, which is really shorthand. We have this little shorthand way called cis, C-I-S, which is cosine cis is cosine I sine. So when you see this cis, that just stands for cosine I sine. So we're going to take it from writing it in its complex form. That's also called its rectangular form. We're going to take it from writing in its complex form to writing it in its trig form. So the trig form is based off two things. It's based off of R, which is the absolute value of the complex number, and theta, which is basically the angle of the reference angle associated with that complex number. And that reference angle would be found right here. So that angle is based off the tangent of B over A. So R is equal to the absolute value of Z. So R is the square root of A squared plus B squared. And the angle, the theta, is equal to tangent of B over A. Now, we're going to eventually get into this here in a second. You'll see this a little bit more clearly. But the big thing you need to remember about finding the angle when we deal with this is you need to graph it. Because remember, there's always going to be two angles on the XY axis on that period from 0 to 2 pi. There's two angles that will always have the same tangent. So you need to make sure you always grab the right angle. So graph it to make sure you see it. So what we're going to do to begin with is I'm going to do one, then you're going to do one, then I'm going to do one, then you're going to do one. First part is we're going to translate this from standard form to trig form. Some people would call this polar form, but we're going to call it trig form. So the first thing we have to do is we have to always go through and figure out what R and theta are. So before we figure out R and theta, I would first recommend you graph it. So A is a positive number here. It's a positive root 6. B is a negative number. So B is a negative root 2. So positive A, negative B. It's very similar to a positive x negative y. So that means it's going to be down here in quadrant 4. So this is that value right here. This is the value of root 6 minus root 2i. So when we get to the theta part, we know kind of what we're looking for here. So when we get to the theta, you can kind of see what that angle is that we're looking for. So I'm expecting when I do my tangent, I'm going to be getting a value that is going to be a negative theta. All right. So r squared, or the square root of r, is a squared plus b squared. So r equals the square root of a squared, which is root 6, plus b squared. So plus negative root 2 squared. So we got to go through first of all and figure out what r is. So r is going to be the square root of 6 plus 2. So r is the square root of 8. Which is the same thing. If you wanted to, you can. You don't have to. So don't feel like you have to simplify the square root. Again, we really don't need to. We can leave it as root 8. But if you wanted to go to 2 root 2, you sure could. So there's our r. Now we're ready to figure out what theta is. We're going to use tangent to help us out with that. So tangent of theta is b over a. So negative root 2 over root 6. So I'm going to simplify this down a little bit. So that's 2 over 6. So that would be a negative 1/3. So we can break that back up again to negative root 1 over root 3. So negative 1 over root 3, which is negative root 3 over 3. So we do a little bit of algebra just to kind of clean it up to figure out where on the unit circle we are, if we are on the unit circle. If we're not, we're going to get ugly, ugly decimals, which would be kind of a bummer. So tangent of theta is negative root 3 over 3. So that means my theta, I have to figure out which angles are dealing with negative root 3 over 3. Well, that's going to be in quadrant 2 and quadrant 4. So that would be either 5 pi over 6 or 11 pi over 6. So one of the reasons why we graph this is there's going to be 2. If you plug it into your calculator, remember, it's going to be dealing with, it'll be tan inverse. It'll be dealing with arctangent. So it may actually give you a negative pi over 6. Matter of fact, that is what your calculator will give you. But that's not on our fundamental period. So we're either at 5 pi over 6 or 11 pi over 6. Since I know this is in quadrant 4, I know that I'm dealing with 11 pi over 6. So now I have my theta, I have my r, so that means z of root 6 minus root 2i is the same thing as r cis, C-I-S. So I got my r value, theta. My theta is 11 pi over 6. And we're done. All right, guys, why don't you guys go ahead and pause the video for a second and see if you guys can't figure out how to do number 2. All right, take a look at it. Okay, let's see how you guys did. First thing, hopefully you all did was you actually went through and graphed it. So let's see here. Negative 2 and negative 2i root 3, that's going to be up here. So that's our z value. So now that I know I'm going to be in, whoopsies, put it in the wrong spot, didn't I? There we go. So that's going to make it be negative 2 minus 2i root 3. So that's the value we're looking at, which means Here's my R value. I'm looking for this angle right here. And I had -2 as my A value and -2√3 as my B value. So we figure out R. Hopefully you guys did that. And we ended up with -2 squared plus -2√3 squared. So that means R is 4 plus 12. So 4 squared is 16, which is 4. So R is 4. So what we got to do now is we're going to go through and we're going to figure out what theta is. So tangent of theta is -2√3 all over -2, which would be a positive √3. So I'm looking for where tangent of theta is √3. So when I think about my unit circle now, I'm going to be either at pi over 3 or I'm going to be at 4 pi over 3. Since I'm in quadrant 3, I want it to be the 4 pi over 3. So now I have my R value and I have my theta. We can go through and actually write it in its trig form. So Z is 4 cis 4 pi over 3. All righty. Hopefully you guys are feeling pretty good about translating it that way. What we're going to do now is we're going to go from trig form to standard form. So to go from there, if we remember that A, oops, let me draw this out for you a little bit so you can kind of see how this whole thing plays out. So if we have some value here, here's my theta, here's my R value. So A and B would be located on the triangle. So that means that A is R, and I drew A and B in the wrong spot. That's embarrassing. There we go. A is equal to R cosine of theta. And B would be equal to R sine theta. So when I'm dealing with this and translating it back into its complex form, I'm just trying to take my R and my theta and using it to come back to A and BI. So this one, to get A, it's going to be 3√2 cosine of pi over 6. And B would be 3√2 times sine of pi over 6. So we evaluate our trig expression real quickly. So 3√2 times cosine of pi over 6, that's going to be √3 over 2. So that means A was almost a 3. There we are. A is going to be 3√6 over 2. When I plug my B value in, I get 3√2 sine of 1/2 oopsies, times 1/2. So that means I end up with 3√2 over 2. So when I take it now out of its trig form to get to its complex form, I have A plus BI. 3 root 2i. And now it's in its complex form. So I can go back and forth from trig to complex. Why don't you guys go ahead and try the one below it and see how you do. All righty, let's see this here. We have A is 7 cosine of 5 pi over 4. And B is 7 sine 5 pi over 4. So 7 times negative root 2 over 2. And over here for B, we have 7 times negative root 2 over 2 again. So that means A is negative 7 root 2 over 2. B would be negative 7 root 2 over 2. So that means our Z value then is going to be A plus BI. And I should probably make that A minus. All right, so we've gone through real briefly and we looked at how we take a complex number and put it into trig form, or how we take a trig number or take a complex number in its trig form and move it back to its standard form. So now the last thing we're going to have here is we can actually go through and multiply and divide some of these trig functions. So basically, and we're not going to overthink this too much, when you're multiplying, when we're multiplying, we go ahead and we multiply the R values, but we add the angles. When we're dividing, we're going to divide the R values, but we subtract the angles. In a lot of ways, they kind of act like exponents in that regard. So if they're not in standard form, put them in standard form, and then you can go ahead and figure it out real quick. If they are in standard form, put them in trig form, and you actually can do it pretty quickly. If they are in trig form, great. Just leave them alone, and you can do this really, really, really quickly. So what we're looking at here is we're going to be multiplying and dividing complex numbers. So quick little reminder here how this works. When we multiply, we're going to multiply the R values, and then we're going to add the angles. When we divide, we're going to divide the R values and subtract the angles. Now, tomorrow, we're actually going to do something really cool. It's called de Moivre's theorem, where we actually take the roots of them and we raise them to powers as well, which is really a pretty cool idea. So, but today we're just going to do a couple operations and we'll call it a day. So let's see how this works. When I want to multiply these two, I'm going to take the R values and I'm going to multiply them together. So 9 times 4. And then I'm going to take the angles and I'm going to add them together. So 2 pi over 3 plus 17 pi over 6. So when we multiply, we end up with 36 cis. 2 pi over 3 is 4 pi over 6, so that ends up being 21 pi over 6, which is the same thing as 7 pi over 2. you wanted to, you could take it, you could multiply it all the way out if you really felt like it. You could do that. You don't have to, but I mean, you definitely could do that if you wanted to. All righty. And then when we divide them, we are going to divide the r values. So 9 divided by 4. And we're going to subtract the angles. So 2 pi over 3 minus 17 pi over 6. So when we divide them, we end up with 9 over 4. Oh, it's going to be December in 2 days. We're 27 days from Christmas. It's not too bad to go ahead and use a little red and green here. Negative 13 pi over 6. All righty, friends. And I'm not going to put that one out. I'm going to go and just leave that alone, because we can leave it in its trig form just A-okay. But why don't you guys go ahead and take a second here and see if you guys can actually multiply and divide the complex numbers. All right, go for it. All right, let's see how you guys did. Okay, so Z1 times Z2. We end up with 6 times 8. Cis. 4 pi over 3. Plus 3 pi over 4. And that's going to be the same thing as 16 pi over 12 and 9 pi over 12. So let me go ahead and get ourselves a common denominator here. So 48 cis 16 pi over 12 and 9 pi over 12. So overall, that'd be 25 pi over 12. All right. Now, let's go ahead and finish up this up here. There we are. Okay. And now we're going to go ahead and divide them. So Z1 divided by Z2. There we go. That would be 6 divided by 8. Cis 4 pi over 3 minus 3 pi over 4. So in other words, 16 pi over 12 minus 9 pi over 12, and we already have those over there. So we can go ahead and do this one a little bit quicker here. So 6 divided by 8 would be 3 halves. Let's try again. 3/4. There we go. Cis 7 pi over 12. And friends, we are great. All right, we'll come back tomorrow and we will take a look at the second part, complex numbers and trig functions, just to see how they relate. So have a great evening, and I will talk to you guys tomorrow in class.